everything done there. Yep. Okay. So use the change of base formula to evaluate the expression. This is not going to be nice. I mean, if I change this to 13 to the x power equals 19, there's no nice number that's going to work for that. This is why they're telling me to use the change of base formula. And may I remind you what that is? Log of the argument divided by log of the old base. Now you get to pick whatever base you want. What base does it appear that I chose? I'm pointing to it with my red pen. What is the base that I'm pointing at? It's also right there. Whenever you don't see a base, you know it is 10. That's a base of 10. Now, I told you if you wanted to write it in, there's nothing wrong with writing base 10, but it is not necessary to do that. When you go to type it on your calculator and you do log 19 n parenthesis divided by log 13 n parenthesis, you will not see a base written down on the calculator screen. That's because it's assumed to be known that it's base 10. That's called a common log. I use base 10 because your calculator is programmed to handle it. And if you type it on Desmos, you're going to get, you can just type log 19 on the top and log 13 on the bottom. Any questions on that? If you need to, draw arrows so you know that, okay, this 19, that one went to the top, and this 13 went to the bottom. If you need something like that to help you, then write that down. Draw arrows so you know. Do me a favor, go to question 6 right now. Go to question 6. Use question 3 to help you with question 6. Take a stab at it. Go to question 6. Hold on a second. Saw lots of you choosing letter choice D. You would be correct. Log of the argument over log of the old base. So, when they said 2 common logs, you should immediately have known that was base 10. Well, look at this choice. That's base 11. That's base 14. That's base 7. This is the only one that's base 10. They didn't even give you a good fake answer. I mean, they could have at least written it down upside down as a multiple choice answer just to see if you'd bite for that one, but they did not. So, I'm glad to see many of you chose that one based on what we did on question 3. Okay, we'll jump back up to question 4. We've got log properties to talk about. And so I see multiplication inside there. That would obviously be property number 1. We know that multiplication goes with addition. So that's that whole multiply and add thing going together. So I could have log base 7 of 5 and log base 7 of 2. What's going to go in between those? Using property number 1, what's going in between? Addition. Thank you very much. And that's the end of that question because that's all they asked me to do was expand it. Somebody, the first period, did ask, well, what if I actually find that number? And I was like, you know what? Guess what? If you decide to find that number, I could probably give you extra credit because that means you're using the change of base that we used at the top on question 3, right? You'd sit there and you'd multiply those things together and you'd get log base 7 of 10. Folks, this is all extra. This is not necessary, what I'm writing over here. So, you'd have log base 7 of 10, and then, of course, you do log 10 over log 7. And, you type that on a calculator and get some weirdo decimal. Okay? So, if you wanted to do that, fine. But that's not what the question is asking you to do. This is a full credit answer right here. Question 5. I see division. Okay? I know that division goes with subtraction, and that's from property 2. So we have log base 7 of 7 and log base 7 of y. What should go in between? According to property 2, how do you take division and split it up? Subtraction. That's it. So very similar, very simple, like the last question. Any questions on 4 or 5? Jump down to the bottom of the page, question 7 at the bottom. The first thing I see is this coefficient needs to be brought up and made into an exponent. That's property 3. That's the old King Julian property. And so he's telling me to move that exponent, and so that I would have log 2 to the third plus log 7. Do we know what 2 to the third is? 2 times 2 times 2. Anybody got 2 to the third? Two times 2 times 2. That's 2 to the fourth. That's 2 to the fourth. That's 1 extra power. What's 2 to the third? That's just 8. Thank you. Yep. So now I see addition. That's property number 1, right? So we used property number 3 at the beginning of this problem. Now we're using property number 1 to take the 8 and 7 and do something with those, creating a single logarithm. What does property number 1 tell me I should do with the 8 and the 7? You could see it back in question 4 on your own page if you wanted to see it. What am I supposed to do with the 8 and the 7? What did we do? Okay, so what am I supposed to do with the 8 and the 7 based on what I see up here? Whoa, sorry, it's not frozen. What am I supposed to do with the 8 and the 7 based on what you see here? Addition goes with what? Multiplication. So we should multiply the 8 and the 7 together. So my final answer to this would be log of what number? 56. 8 times 7 is 56. Okay. Next page. Beyonce would tell me to look for single logs. Is that a single log? On the left-hand side, is that a single log? That's a big yes. Alright, so that means we can switch to exponential form. Switch to exponential form. And we would use boxes like this. Alright, what's the base? I'm pointing at it right now. It's a base 10 logarithm. Thank you very much. My choices for exponent are 1 or 59 minus 7x. Which one is the exponent? 1 or 59 minus 7x? Well, hopefully you remember what I said to you several times, that log means exponent. Can I do what? Ask your question. So, Which one of those is my exponent? Is it 59 minus 7x, or is it 1? Which one's the exponent? If log means exponent, it's actually right over here. Right over here. This side of that is my exponent. So when I go to put it in my box, it would be the exponent place. That leaves me with one box remaining, which is the 59 minus 7x. Now 10 to the first is more commonly referred to on the street as 10. And this looks a lot like something we did back in Algebra 1. So we could subtract the 59 over, which would get us negative 49 equals negative 7x. And then, of course, we would divide by negative 7 to get our final answer of positive 7. Questions on that one? As soon as you see a single log, you know you can change it to its other form. Question 2 is the exact backwards of that. It's starting in exponential form. I have to change it to log form. So out of 5, 2x, and 13, which one of those is the base? 5, 2x, and 13. Which one is the base? It is 5. Thank you very much. We know that the exponent goes over here on the other side of the equal sign. So is that 2x or 13? Which one of those is the exponent? 2x or 13? That is 2x. That leaves one box left, which is 13. So now that we have it in its exponential form, we have to use the change of base theorem. So that would be log of the argument over log of the old base. And of course the other side of the equation is just 2x. And of course I'm going to use my handy dandy equation or calculator because I don't know that. Log 13 divided by log 5. And it gives me a really weird answer of 1.594. We know that's equal to 2x. What is the last and only thing I'll need to do to solve this equation right here? Got to get x by itself. Divide by 2. Yep, and when we divide by 2, we end up with x equal to 0.797. Very ugly looking number. As long as you're willing to show me the work, I don't care exactly where you're rounding to, as long as I can see your work. And if you do these kind of steps and then round it to 0.8, okay, not a big deal. Okay, question 3. Do we have a single log here? Yes or no? No, we do not. So we're going to have to use one of our properties. And, of course, that's going to be, since I see subtraction there, that's going to be property number 2. Property number 2. So we can split that, or combine that together to create one logarithm. X plus 11 is in the top, and 2 is in the bottom. Of course, the other side is pretty straightforward, log 5x plus 2. Get that written down, and then I got one question for you. If the left side is equal to the right side, and the bases of these logarithms are the same, what do we know about those two arguments? If these two things are equal, which we know they are, and the bases of the logarithms are exactly the same, what do we know about the arguments? They have to be what? They have to be the same, exactly. So I'm going to make a new equation. Without logs. X plus 11 over 2 equals 5x plus 2. Now, you and I both know that anything can be divided by 1, so I'm just going to write it like that so that you see that this is a proportion, folks. And how do we handle every proportion in the universe? How do we handle every proportion in the universe? Back in middle school, some of your teachers told you to use a butterfly. I'm not really a fan of that analogy in this situation, but what was your middle school teacher trying to remind you of? Okay, I guess cross multiplication. So we would have 1 times x plus 11 and 2 times 5x plus 2. Well, 1 times x plus 11, that's pretty boring. But then over here, I'd have to distribute the 2. So how many x's am I dealing with? 2 times 5x is 2 times 5x, 10x, and 2 times 2, 4. So now it looks like an Algebra 1 question, right? Looks very straightforward. Subtracting an x from both sides. That'll bring the x's over here. And then we'll move the 4's over to the other side by subtracting a 4. And so we end up with 9x on that side and 7 on this side. And the last thing to do in this entire equation is what? Divide by 9. Now, I don't care if you leave your answer as a fraction, 7 over 9. That's a good answer. If you're a decimal fan and you change it to 0.7 repeating, that's a good answer. If you like 0.78, that's a good answer. Just show your work. Obviously, I'm looking for these steps over here to show that you know what you're doing. Giving me a decimal or a fraction answer is not a make or break. Okay. Question 4. We're starting out with $7.95 per hour. Hopefully this was 1980. Yeah. Because back then that would have been good, right? I mean, if gas is going to be 50 cents a gallon, then maybe we're okay with this amount of money. But most of us wouldn't be okay with it now. So, $7.95 an hour, and you're getting a 4% raise each year. They have given me the equation right here. So that was nice of them. It says find out how much, or after how much time will this person be earning $10 per hour. So they gave me a new Y value, and I'm supposed to plug it in. 10 equals 7.95 parenthesis 1.04 to the t power. We are trying to solve for t. So, just like we did the first time we did this question, we divided by $7.95 on both sides. And I'm not going to know what that number is. Neither are you, so let the calculator do the work. $1.258 equals 1.04 to the t power. The 7.9's cancel out there. Well, nobody in the room is going to be able to do that unless we use logarithms. So we better fill in the boxes of the logarithm. Of your choices, 1.258, 1.04, or t, which one of those is the base? Which one of those is the base? 1.258, 1.04, or t, which one's the base? Up in question 2, we had a similar situation, and we said that the base was 5. So that's what we looked at. We looked at this number right here and said the base was 5. So you tell me on question 4, when you're looking at 1.258, 1.04, and t, which one's the base? It's one of those three. Thank you. 1.04. Yes, I'll do it. The exponent goes on the other side. Is the exponent t or 1.258? Which one is the exponent? I hope you know it's t. That leaves me with 1.258. Those are some nasty, ugly numbers, folks. But the good news is we got a calculator. And we know from a few of our previous questions, like number 3 and number 6, that we did earlier at the beginning of the period, we took the log of the argument over the log of the old base. Log of the argument, and we chose base 10 so that we could use our handy-dandy calculator. Log 1.258 divided by log 1.04. Hopefully you remember typing these things on calculators or Desmos. And in this particular case, we get a t-value of 5.85 years. 5.85 years. So it would take us almost 6 years to get to $10 an hour, which maybe back in the day would have been nice. But, I mean, I remember my first job in 1988. I was corn detasseling, and I made $3.60 an hour. So $7.95 would have been fantastic. But things cost a lot less back then, you know? You know, AirPods were like $15. You know what I'm saying? It's just an analogy, folks. We didn't have AirPods back then. Okay. What? You making fun of me? Okay. All right. right, do we have a single log here on the next question? Single log, yes or no? That's a no, thank you very much. So we have to use, in this case, property number 2. Property number 2 to combine these together. And we've used that one. That's the one that talks about division. So we would have 15 in the numerator and 2x in the denominator. That's a single log. And of course 1 on the other side. Now, just like the first question we did at the beginning of this, at the beginning of class today, we would change this to its other form. Once you have it as a single log and you don't know what to do with it, you better change it to its other form. Okay, folks, what's the base? I'm pointing at it with my pen. It's a base 10 logarithm, right? When you don't see the base, you know it's a 10. Out of your choices for exponent, you have 1 or 15 over 2x. Which one of those is the exponent? 1 or 15 over 2x. Well, I hope you know by now, since we've pounded this into the ground, that it's on the other side of the log function. So, it would be a 1, which would leave me 15 over 2x in this box. Most people call 10 to the first 10. And anything can be divided by 1, so you can clearly write 10 as 10 over 1. The reason I do that is so that you see that it's a proportion, and how do we handle every proportion in the universe? Cross multiply 1 times 15 and 10 times 2x. 1 times 15 is pretty easy, 15, and 10 times 2x is 20x. Breakfast today? And we divide out the 20. I thought you were making one of those. What is it? ASMR? ASMR videos back there or something. Okay. Yep, I didn't know what she was doing. Okay. I was like, so 15 over 20, do you think I would accept that as an answer? Sure, how about 3 over 4? Would I accept that as an answer? What about 0.75? Would I accept that as an answer? Sure. Folks, I'm not picky about that stuff. If you're going to show me all this work, that you know how to change something to a single log using property 2, and you know how to change it into its exponential form and cross multiply, I ain't arguing with that stuff. So, any of those answers would do. Right here. I'm just going to abbreviate that as a single log. Hopefully you say no again, and then you see addition, so you think, oh, I need to use property number 1 to write that as log. What are we going to do with the 2x and the 1x? What do we do with the 2x and the 1x? We're going to multiply them together, 2x times 1x. And what do we normally call 2x times 1x? Okay, I'll do it. 2x squared. 2x squared. Well, since we've got it as a single log, just like the last question, we had to change it to its exponential form. What is the exponential form for this? What's the base? 10. Your exponent choices are 2x squared or 8. Which one of those is the exponent? Hopefully we know the exponents on the other side by now. So it's an 8. 10 to the 8, that kind of reminds me of my savings account. So the remaining box is 2x squared. If you didn't get that joke, you probably shouldn't get a very good grade in this class. If you did, you might as well get an A. You know what I'm saying? Okay. So 10 to the 8th power, well, that's a 1 with 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. So what is that, 100 million? Yes, it's 100 million. So what are we going to do to solve this for x? There's 2 things left and we're done. Should we divide or square root? Which one should we do? Divide by 2 first, thank you very much. Giving me 50 million equals x squared. 50 million equals x squared. So, what do we do now? Of course we do the square root. And if you do that square root, you're going to end up finding out that x is about 7,071.1 if you type that on a calculator. Okay, hopefully you have that. Any questions on that one? Okay, flip the page. 2 more to go. Now take a look at this one. It looks like we got a single log on both sides. That's convenient for us. I also noticed that the bases are both 2. What does that mean I can do? If the left side equals the right side and the bases are the same, what do we know about x plus 1? What do we know about x plus 1? On the previous page, we had a very similar question that was just like this, okay? And so you guys told me that x plus 11 over 2 was equal to 5x plus 2. And so we rewrote the equation without logs. Can't we do the same thing here? So what do we know about x plus 1? What does it equal? Come on, folks. We're almost done. What's it equal? Don't act like you're blind. I know you can see this. What is the x plus 1 equal? I mean, is it really that hard to see? 5. Yes, it is 5. This was probably one of the easiest questions of the entire day. You can look at that and you can rewrite. Okay, so rewrite without logs. X equals 4. Like I said, easiest question of your, of everything we did today. Question 8. Last question here. Looks like a single log already, so that's good news. So we can immediately switch to exponential form. What's the base? Your choices are 3, x minus 3, and negative 2. Which one is the base? 3, x minus 3, or negative 2? Which one's the base? 3. So, now I'm looking for the exponent. Well, hopefully by now you know that the exponent of a logarithm sits on the other side. So that would be negative 2, leaving me one box remaining, which would be x minus 3. Now, I don't care if you rewrite this as 1 over 9 equals x minus 3, or if you type that in a calculator and get 0.1 repeating equals x minus 3. It doesn't matter to me. What are you going to do to solve this last equation and get x by itself? Last thing. Well, that's not the opposite of subtraction. What is the opposite of subtraction? There you go. So we're going to add 3. Yep. Right. You're trying to get rid of that. Right? We want to get x by itself. So I don't care if you give me 3.1 repeating. I don't care if you give me 3.11. I don't care if you give me 3.1. I don't care if you give me 3 1/9. If you're a fan of any one of those and you show your work, you got it. Any questions on any of those?